to yet another class on equilibrium of particles. Now this question says, if the cylinder at A in this figure here has a weight of 20 newtons, so we're using newton in terms of pounds now, 20 newtons, not 20 pounds, determine the weight of B and the force in each cord needed to hold the system in the equilibrium position shown below, like this. Determine the force, right? The weight of B and the force in each cord. So how many am I looking for? How many cords do I have? Cords from G to E, that's one cord. From E to C, that's yet another cord. From C to D, yet another cord. So 3 cords there. 1, 2, 3. And then they say the weight at B. That's it. So I'm looking for 4 things, basically. Alright, so let's get this done. How do I start from? Where do I start from? How do I start? And where do I start from? For this question here, you start from this point and do some analysis. So start from here first. Let's get 3 point diagram from here. So for this, I want to do this first. Let me assume here as my first Cartesian plane here, like this. Alright, so with this line, that's this. That's this. What do I have? I have this one coming down here, 20 newton. So I have 20 newton coming down. I have TEG this way. So I have this way here. This is tension from E to G. Okay. What else? I have this one here. TEC or TCE, same thing. So I have this way. Something of this nature. So this is C. Whether I call it EC or CE, it's the same thing. Alright? But now let me call this EC. If I choose to change to C, it's the same thing. Alright. So there. Let me put my angles here. Alright, so this is the concept of alternate angles. If here is 45, this is the alternate. So here also becomes 45 degrees. So that means TEC is inclined at 45 degrees. This concept is from alternate angles. So 45 degrees. So I have this. What about TEG? Let's say this. Still the same concept of alternate. I have this line here. If I still choose to extend it upwards like this, so this and this are parallel. So the same concept here. This one here and this are parallel. So this angle equals this. The same concept here. This one here and this are parallel. So this angle here equals this one here. So hence, if I extend this one here upwards, this angle here, this one here, which is this one here, is equal to this. They are called alternate angle. This is equal to 30 degrees. Alright, so we have this. Yeah, quite something. So we can now start off with this one here. Alright, so I had to clean this so we can get our original diagram back. So that was this. I only did some analysis to get all of this. Alright, so let's get this done. As usual, summation of vertical forces, summation of horizontal forces, and if need be, we can use moment. So, summation of vertical forces, sigma fx is equal to summation of horizontal. Alright, so at this point now, we'll take the next thing there. That's summation of forces, whether horizontally or vertically. And we can use moment if need be. So let's look at summation of horizontal forces equal to 0. We're saying this way like it should be positive. Alright, the direction positive. So what do you have here? We have this one, we have this one. Now, observe that this one is inclined at 30 to the vertical. So you should know how we should resolve this. It now becomes a sine, not a cos, because of the angle of inclination. So I'll have TEG sine 30. This is the horizontal component. Alright, this one here, if I resolve this TEC, this way, becomes negative So minus T EC cos 45 equal to 0. So hope you get what we just did here. Alright, so this one is sine because of the angle of inclination is to the vertical. We've explained this in our very first class on resolution of 2D forces. Also, this one here is inclined to the horizontal, as you can see there. So resolving this becomes a cos. If I resolve it this way now, it will be pointing in this direction, which is the negative. Here is positive, so here it becomes negative. So negative cos this. So I have this value. Alright, so do you have anything there? No. So I will call this my first equation. Next up, summation of vertical forces is equal to 0. It's going upwards to the positive. We can resolve this one upwards. In this case, it becomes cos. I'm having TEG cos 30 because of the angle of inclination. So it's cos. It's going upwards, it's positive. This one is coming downwards, minus 20. This one also can be resolved this way, downwards, because it's inclined with an angle. So you can have horizontal and vertical components. Resolving this way becomes negative. So minus the force here, TEC, and of course sine. So sine 45 is equal to 0. So this summation of vertical force is equal to 0. This one resolved this way because of the angle becomes cos. This one coming downwards, negative. This one resolved this way, negative, and sine of the angle. Alright, so if you've done this, let's get my done. Move 20 over here. I'm having TEG cos 30 minus TEC sine 45 is equal to minus 20 comes and becomes plus 20. Call this equation 2. So I now have two equations to work with. This is in terms of TEG, TEC. So at this point, I can solve 1 and 2 simultaneously. Alright, so I'll solve 1 and 2 simultaneously. So we can get this. Let's see what we get. Okay. TEG sine 30 minus TEC cos 45 cos 25 equal to 0. So we have TEG cos 30 minus TEC sine 45 equal to 20. Alright, so let's get this done. So this is equation 1, equation 2. So depending on how you want to solve this, you could use substitution method. Substitution from here, from equation 1, we have that TEG sine 30 is equal to, the minus comes and becomes plus, becomes equal to TEC cos 45 divided by sine 30 divided by sine 30. So this cancels this. So TEG is equal to, we'll just do this brief mass. Just do cos 45 over sine 30. cos 45, let's get this done, cos 45 divided by sine 30, that's about 1.4142, yeah, then TEC. But this value is from cos 45 over sine 30, 1.4142 TEC. Alright, so put this TEG value into, so we got this one from this equation 1. So put that into equation 2. That means TEG we said is equal to 1. So in place of TEG, I'll put this value instead. So I'll replace this by this value. So it becomes 1.4142 TEC. That's TEG. Then next up, cos 30 minus TEC sine 45 equal to 20. Alright. So I'll just punch 1.4142 cos 30. So 1.4142 cos 30. About 1.2247 TEC minus 1.2247 TEC, okay. So minus sine 45. So this one here is about 0.7071 TEC is equal to 20. So TEC, we can subtract their coefficients. So 1.2247 minus 0.7071, that's about 0.5176 TEC is equal to 20. So to get TEC, simply divide both sides. So now divide here by 0.5176. Divide here by 0.5176. So this cancels this. Let's get TEC. Alright, so therefore the tension for EC is equal to, what do you get there? 20 over 0.5176. That's about 38.64. 38.64 Newton. That's the value of TC. 38.64 Newton in 2 decimal places. Alright, so you can get TEG from there. But we said that TEG is equal to 1.4142 TEG. TEC. So let's replace values. Alright, so TEG is equal to 1.4142. TEC is about 38.64. Alright, 38.64. Alright, so TEG then is now equal to 1.4142 into 38.64. About 54.64 Newton. Alright, so far so we've gotten two values. We've got the tension from E to G, TEG, that's about 54.64 Newton. We've also gotten the tension from E to C, that's TEC is equal to, we got that as 38.64 Newton. With this, we just analyze this point, and next task will be to analyze this point. So I'll take down these two values, that TEG is 54.64 in Newton, and TEC is equal to 38.64 Newton. Alright. Alright, so our next task would be to analyze point C. So at C, let's look at C. What do we have? We have this point here. C. At C, this one is coming down here. This is B. Okay, let's draw free body diagram. We have to draw free body diagram. So what we're asking here is just weight of B. So weight of B, WB. I have this angle here. This space here is T from C to E, CE. And please note that TEC is equal to CE. Alright? So please note that TCE is equal to TEC. Right? It's the same chord. They're the same chord. So the tension on the cord will be equal throughout. So it's the same thing. Alright. So TEC, let me add it here, which is equal to TEC is equal to TCE. Alright, very important to note. And the angle here, we said is 45 degrees. So 45 degrees. We now add to that one here. This force here, that's TCD. We have this one here. This is 3, this is 4, this is 5. Alright. So this one is not a problem. We have an angle, so we can resolve. TCE, we said it's equal to 38.64 Newton. Alright, so the next step will be to get this mark properly. So how do we do this? We'll call here theta. So get sine and cos of this angle here. Let's call this theta, okay? So sine theta opposite phi 3 all over hypotenuse phi. Cos theta is equal to adjacent 4 all over hypotenuse phi. So I think for this we can now solve this. Alright, so let's use the conditions for equilibrium. The first condition, summation of horizontal forces equal to 0. It's going to the right, it should be positive. So what do you have there? You have this one resolved here, this one resolved here. Alright, the angle of inclination is to the horizontal, so it becomes positive TEC. Then of course, cos 45. Next up, we resolve this one this way to be negative, then TCD, then of course, resolving this becomes cos of the angle theta. Let's call this theta here, of theta. It's equal to 0. That's about everything I have for horizontal forces. This one is vertical, so it won't count. So TEC or TCE as we call it. Okay, let me do TCE. TCE as we call it. Yeah, this now becomes 38.64 cos 45 minus TCD into sin theta or cos theta, please. We said is what? 4/5 is equal to 0. Alright, so the task will be simple. I want to get TCD. I'll move this one over here. So this value becomes 38.64 cos 45 is equal to positive TCD into 4/5. 4/5 is 0.8 into 0.8. So to get TCD, divide here by 0.8, divide here by 0.8. So hence, this cancels this. I have that TCD is equal to 38.64 cos 45 all over 0.8, that's about 34.15 Newton. Alright, so of course we've got another one there. TCD is equal to 34.15 Newton. Summation of vertical forces. One last one, please. So summation of vertical forces is equal to 0. Take care the positive. So vertical force, what do I have? So one is going upwards, that's TCE. Use sine of the angle, sine 45. This one is going upwards too, so positive. TCD, use sine of theta, this one here. This one is coming downward, so minus WB is equal to 0. So I have this equation. Alright, impute values. So I have TCE, that's this 38.64 sine 45 plus TCD, this value here, 34.15 is equal to minus WB, shift it here, become positive WB. Alright, so therefore, WB, the weight at B, is equal to this plus this. That's about 38.64 sine 45. I have 27.32 plus this one here, 34.15. So that for the weight at B is equal to 27.32 plus 34.15. That's equal to 61.6.47 Newton. Alright, so I think we've gotten everything. So calculate the forces on the cords. That was 1, 2, 3, which we've gotten as 1, 2, and 3. And then they say the weight of B, which we've gotten here. Alright. So this is how you solve this question.